Since that we mentioned about the mathematical models, equations, or algorithm, I believe most of the engineering students will find themselves reading the mathematical models and algorithms to be quite challenging. Even myself find it to be quite challenging and difficult to comprehend. The reason being is the mathematics and algorithms seems to be quite specialized, complex, advanced, and hardly understandable. It normally involves a lot of unknowns and symbols, and the respective model carries the information regarding their interrelationships. There will be derivations of the mathematical equations, changing alongside with the evolutions in terms of the concepts and the principles, and you will see a lot of symbols and unknown flying here and there. A similar situations you're going to encounter for the algorithms, where there are commands, normally in the computer language, and there are commands over commands. Every command carries an actions and information, which is running along with a specific task to be undertaken by the algorithm. Reading this mathematics and algorithm requires strong fundamentals and the understanding of the first principle. You need to be quite patient and not to be phobia of it. You might need to read words by words, pausing every now and then in order to imagine the derivations as well as the evolutions of the concepts and the principles. It is as if we are reading two languages at the same time. The first one is the text that tells you how the principle changes, and the second one it will be the equations or the algorithm demonstrating the derivations. Of course, you need to be suspicious as the derivations or algorithm might not always work. Because of the complexity, sometimes there are human errors that appear without the knowledge of the author. Sometimes you might also find a gap somewhere in the middle of the derivations, which is not clearly explained by the author, or certain steps of the derivations that have been skipped by the authors before reaching to the next step. In order for you to gain better understanding, you might need to try yourself to fill in the gap. This will help you to gain more confidence and even cross-check if you have properly understood the working principles behind it. Now that we see the challenges of reading the mathematics and algorithm, and we know that most of the engineering research cannot run away from this. Therefore, we will need to accept the fact that we have to deal with it, and we need to increase our competency in order to overcome it. In fact, there is a technique for you to help you gain better understanding when you are reading the mathematics and algorithms, so that you can understand the message being delivered by the author. Understanding these mathematics and algorithms is very important to you. Even though you might not be able to fully utilize them, they will give you some ideas and directions when you need to do some derivations of the mathematics and algorithms to solve your research problem. This is normally how I would do with readings of the mathematics, and I may need to read those several times from the first word to the last word. Regardless how much I hate reading the mathematics, because the needs of the research, I need to be patient about it and going this step by steps. My first step, it will be trying to understand the concept and the flow. This can be acquired by reading the text and explanations before and after the equations are given. You need to know the route from the start to the end. Observe the governing first principles. See how it transforms. Pay attention on the assumptions and the boundary conditions. It involves derivations of some principles. Sometimes they will be synthesizing, combining several principles together, what we call superpositioning, and then observe their relationships. You will see the evolutions of the principles. After mix and match, there will be an outcome, a newly derived theories, and then you observe how they do the validations, what are the acceptance criteria, and so on and so forth. What you are doing at this stage now is trying to understand what the artist is actually doing, what are the tasks being performed, and normally I will put this first because it is imaginable. Therefore, your purpose at this stage is to know how the principle works. Once you have an idea, then you can proceed to the next stage. This will be the stage where you're looking into the alien language. There will be a lot of mathematical equations of algorithms. You need to also read the definitions of each unknowns and try your best to imagine the relationship of all the unknowns within the equations and have a brief idea the information carried by the equation. Next, you can imagine their relationships, their flow, how they are being derived. If you find it very difficult to imagine, you can always draw a flow map starting from the first equations, governing by the first principle, and then observe the derivations. This may include the rearrangements of the parameters within the equations, doing some differentiations, substituting of some equations, combinations of some equations, integrations, and some other mathematical transformations. And then at the end of the day, you will find the final outcome. The purpose of this stage is for you to know the mathematical derivation process. There will be a lot of details involved, and often this kind of the details will be the main variations among different research due to different properties of the material being used, or different conditions, or even different look case and different governing principles. Knowing the mathematical derivation process is helpful for you, as you can always replicate the mathematical derivation process using the details and the parameters that you are using, which may be different from the other, and then you derive along the way. It may lead to you a different outcome. Sometimes you will find yourself may not be using the entire derivation process given by a same author. There could be mix and match from the other's papers, where some parts of the derivations may be adopted and more appropriately represent your conditions. This will be the part that makes your research to be rather unique and different from the others. Once you have done this, you might need to think of the verification process, due to the fact that you need to be suspicious, as the derivations of the algorithm might not always work. That is one thing. Another thing is to help you to troubleshoot your understanding that you acquire in the first and the second stage. Probably you overlook certain things, or you misunderstood something which you think yourself has fully understood, but at the end of the day, you realize that it doesn't work. Although the derivations or the algorithms given by the author actually work. Therefore, you are encouraged to reproduce the derivation process in order to verify this. You may try to derive yourself, or you may have another idea, a more simplified methods to achieve the same outcome, which you would like to test yourself whether it is workable. With that, you may try to reproduce and derive yourself in accordance to the flow given by the author. The purpose is to confirm the correctness of the work, and in the case of having a new idea to achieve the similar outcome, where you would like to test your idea, you may incorporate your own derivations using the data given by the authors in order to check whether your idea is workable. What you see here, the process for you to understand the mathematics and algorithms seems to be quite tedious, and I would say that this part most likely going to consume you most of your time in order for you to fully understand it. Sometimes it can be quite frustrating, especially when you start somewhere, unable to fill in the gaps in between two different steps, or due to some limitations in terms of the mathematical understanding, you may not be able to acquire the outcomes as given by the author. This is okay actually, and normally this cannot be achieved in one go, so you could put it aside for a while and then come back to it later. If you know your limitations due to some understanding of mathematics, probably you need to learn the mathematical derivations from the other sources. Most of the time you will find yourself lost also, manage to acquire understanding during the first half of the derivations, and then because of the missing link somewhere in between, you don't know how to proceed. This is also normal, and you don't have to be disheartened, as this is a typical learning process. I believe most of the postgraduate students will encounter the same. Frankly speaking, even those experienced researchers, such as your supervisor, may sometimes have difficulties to understand complex mathematical derivations. You will need a lot of trying and error, a lot of practice, a lot of reading. Probably you need to consult somebody to accelerate the understanding process if you really need that part in your research study. I presume that most of the students, when they come to the stage that they need to fully understand a derivation process, it is normally towards the later stage of their research. Most likely by this stage, they should have some data as obtained from the experiment or simulations, and then now they would like to transform them into some theories or equations model to represent these situations. By that stage, your directions of the research is more or less quite clear. Probably you are at the stage of testing several derivation approach for you to complete the research project. If you really stuck somewhere and unable to overcome it, no matter how hard you try, maybe you can go for other options. See if there is any simpler ways to achieve that or to bypass that without compromising the qualities of your research work. You have to believe that there is always ways to overcome something. As long as you work hard enough, you will encounter it.